Welcome to part 2 of case study ex2, where we'll continue to show how to apply key operators in RxJava's observable class. In particular, in part 2, we'll explore how various RxJava observable operators we didn't cover in part 1 can be applied to create large random big integer objects in one thread and then asynchronously check to see if those numbers are prime in another thread. As usual, you can find the source code in the link at the bottom of this slide. Once again, we're in my IntelliJ project for case study ex2. Let's take a quick recap through the ex2 class, which, as you can see, as usual, provides the main entry point into the test program. In part 1 of the video, we took a look at the test_is_prime timed method, and now we're going to take a look at the test_is_prime async method. And this method will test a stream of random big integers to determine which values are prime using an asynchronous observable stream. And this is actually kind of a cool producer-consumer style algorithm because we have two threads that are being used. As always, we register both of these methods under test with the async task barrier. We then run the async task barrier, which will run all the computations in the background asynchronously, and then the calling thread will block with a blocking get, waiting for the results to finish. Let's go ahead and take a look at the observable EX class. This is where all the fun stuff happens. For completeness, I'm going to do a really quick recap of the fields we're using here. If you want a longer discussion, go back and watch part 1. Very quickly, we keep track of the maximum random number to generate, the number of iterations to run. We compute something called lower bound, which is the max value minus the iterations to get duplicate values. We make a random number generator. We're going to have a memoizing cache using a concurrent hash map to do some cool things so we can look up values if they've been computed already and not have to recompute whether they're prime. We have something that keeps track of sleep duration. We don't actually use that for this particular test. That was used for the interval test that tested things using the interval operator on observable. We do use this predicate called s_only_odd, which will only allow odd numbers to be put through the filter. We have a function that generates random big integers by using big integer value of in conjunction with our s lower bound and random number generator. And then let's go ahead and skip through the is_prime timed method because we've already looked at that. And let's talk about test_is_prime async. So as always, we create a string buffer to hold the results we're going to display at the end. We make ourselves a little local variable called log big integer that we use to write the big integer values to a string buffer that we just allocated ahead of that. And here's the main outer observable chain. So you can see what we're going to do is we're going to have a bunch of methods that are called in an observable fashion, starting with the create factor method that will create a stream of random big integers that are going to be generated in a background thread. And I'll show you how that works in a second when we take a look at the emit async method. That's something that we write to generate the big random integers. We then go ahead and use the do on next action operator to log those results so we can see what's happening. Now, here's something we do that was different from last time. The last time in part 1 of this video, we used the observable interval operator and we ran everything in a background thread. So the generation of the numbers and checking if they're prime were all done in the same background thread. This time, however, the generation of the numbers, which will be done in emit async, is in one thread, which we call the publisher thread. And over here, we're going to have a different thread that we're going to use that'll be the quote subscriber thread. So this is the one that's going to essentially do the processing to check whether the numbers are prime or not. And to do this, we use the observe on operator and we give it a new thread. So the computations from here, from map to the end, will all be in this other thread. So you can see what we're going to do with the map operator. We're going to check to see if the number is prime. Again, if you want more details of this, go back and watch part 1. But in a nutshell, we use a cool atomic check then act method that's provided by concurrent hash map called compute if absent, which checks to see if a candidate prime number is in fact prime. And if it turns out that we've already computed this in the map before, which just returns the value, which will be either the smallest factor if it's prime or the smallest factor if it's not prime, or 0 if it is prime. Otherwise, we pass in a method or a lambda expression we'll call the is_prime method, which will check to see whether a number is prime, or in this case, a big integer is prime. I won't go through that code, but it's documented and you can see what it does if you know how to compute prime numbers. So what happens next is after we check to see if something is prime, we print the results out, and you can see that printing the results will just print out whether or not it found a non-prime number or a prime number, just to indicate what it found. And then we have a call here to do finally, And if you recall, what do finally does is this is always called whether there's an error or when we get a completion event. And so you can think of it sort of like a destructor in a way, and it will go ahead and be called when the observable stream is about to go away because it's completed all of its processing. So when it's all done, do finally gets called, and that will display the results. The last call here is a call to ignore elements, which will just return a completable that's used by the async task barrier as a flag to indicate that this particular asynchronous computation is done. So that's kind of the processing that takes place in the so-called subscriber thread. Now let's go ahead and take a look at what's going on in the publisher thread. And that thread is going to be running in the context of the emit async method. You can see here's emit async. And this is essentially a factor method that bridges the reactive world of reactive streams with the observable class from RxJava with a callback style world where we're going to be emitting a flow of random big integers in a background thread. So let's take a look and see how that works. So here we're going to go ahead and use the range long factor method operator, which as you can see is going to start at 1 and go up to S max iterations. So it'll generate 10 numbers. We're going to ignore the values of those numbers. We don't care what they are. It's just used to generate 10 signals. We then subscribe this to run in a new background thread, which we're going to call the publisher thread in this context. And then this computation, range long, and all the other computations here up to subscribe and including subscribe will all be running in this background thread. So this is the publisher. And what it does, as you can see, is it's going to generate the random big integer using that function we talked about briefly earlier that will generate a random big integer within a certain range. We're then going to use the filter operator to go ahead and get rid of everything that is even. So if you take a look, you can see here's what we do here. We check to see whether these are odd numbers, and we only allow odd numbers through because there's no sense in checking to see if an even number is prime because we know it's not going to be prime. And then the last thing we do here is we go ahead and have a subscribe call, the terminal operator passing in the onNext method reference, which will just emit those values, pushing them from one thread up to the outer stream that we looked at earlier. If something goes wrong, if there's an error, we say that we're complete. And when we're complete, we say we're complete. So this is basically how we are going to be done when we've emitted basically the number of iterations we have to emit the number of random values we want to look at. So that's what emit async does. As you can see, again, it's called in the context of the outer observable stream. So everything in emit async runs in one thread, that's the publisher thread. Everything that's in this outer stream runs in a different thread, which is the subscriber thread. So if we go ahead and we run this program, you'll see that even though the test is prime async method gets called second in the driver program, it actually finishes much earlier. And that's because the test is prime timed is doing its emissions on a timed basis every half a second. So it takes a much longer time to run. If you take a look over here at the results we get from test is prime async, you can see that this thread here, thread Rx new thread scheduler -1 is where all the emissions take place. And you can see we emitted a bunch of values here. And you can see that in this case, that's where the emissions are taking place. You can see there's some duplicates here, which is exactly what we want, because that way our memoizing cache will do something useful for us. And then down here in the second thread, this is the consumer thread or the subscriber thread, Rx new thread scheduler -2. That's where we're actually doing the checking if something is prime. So you can see that we find that there's some of these values are non-prime. We can see that some of the values are prime. So this value is prime. This value is non-prime. And you can also see that we look things up once we've computed the value, for example, once we've determined that this particular value is not prime, then we don't have to recompute it later. We just look it up in the concurrent hash map. So main difference between the two test programs or the test functions is that this one, the test is prime timed, runs using the interval mechanism, the interval operator of observable. So it pulses out every half a second and everything runs in one thread out of the computation thread pool. And with this other test method, test is prime async, then things run in two different threads. We're emitting in one thread and we're checking in another. So we have a publisher thread and a subscriber thread, if you will. And those are two different threads. And those are threads that we create for the purposes of running the tests. So hopefully now you have a better idea of some of the more advanced factor method operators that RxJava provides, as well as some of its other cool features like filtering and other mechanisms that we talked about in this lesson.